All right, so today we'll be starting off from the book your topic number one, mechanics, in which we'll be studying motion today.
Okay.
And we previously also saw in my lectures as well the different formulas and distance, speed, velocity, vector, scalar, acceleration, the concept for free fall, then another new concept which is going to be resolving the vector component and projectile motion. So let's
Yeah.
start with this chapter with velocity and acceleration. So one of the simplest thing we can measure is how fast an object is moving. That is the object speed by the formula of distance over time. However, if you talk about displacement, which is the shortest distance that can be covered per unit time, we call it velocity, which is displacement over time. So that is known as velocity. Velocity is found by the formula of displacement over time. So what is the difference
Yes.
between speed and velocity and distance and displacement? Can you tell me?
Distance and speed has on is a not a vector quantity, it's a scalar quantity, while velocity and displacement is a vector quantity since they have distance and
Exactly.
magnitude.
Okay, so the main difference is of scalars and vector. A quantity for which the direction must be stated is known as a vector, and if a direction is not important, that measurement is referred to as a scalar quantity. Therefore, velocity is a vector and speed is a scalar and distance is a scalar and displacement is a vector as well. And every quantity can be measured in its own unit as well, and we derive some of the units as well. Whereas there are two more terms, which is the average speed. Average
Mm.
speed is basically the total distance moved in total time. And then there's
Yeah.
another term known as instantaneous speed, which is another very important quantity. Instantaneous speed is the speed of an object at any one point of time. It can be at any one time or at a specific distance. That would be known as
Mhm.
your instantaneous speed.
At that time.
Exactly. Acceleration, on the other hand, is defined as the rate of change of velocity. It must include the direction which the speed is changing, and so acceleration is a vector quantity. And the equation defining acceleration is change in velocity divided by the time taken to change the velocity. That is going to be your acceleration. How, at what rate was your velocity actually changing? Where u is the initial velocity and v is the final velocity.
Final velocity.
When something is not accelerating, okay, when something has zero acceleration, we say that its velocity and speed would be constant. And constant
Okay.
velocity also means zero acceleration. Zero velocity
Mm.
also means zero acceleration.
Zero
So these are
acceleration.
the different formulas. Displacement, the vector measurement of distance. What is a vector quantity? Having magnitude and direction. Scalar, only magnitude. Average speed, total distance over total time. Instantaneous speed would be found at one specific point. If this is the distance and this is the time, this is the graph, what is the
Mm.
was the speed at this point? You can check the distance at this
Mhm.
point and check the time at this point.
And time
That would be your
to find the
instantaneous speed.
instantaneous speed.
And acceleration is measured in meter per second square by the formula of v minus
V
u over t. Then we
T.
also discussed about two different types of graphs. One of them was a speed time graph and the other one was a distance time graph. Can you
Velocity
tell
time.
me what information can we get from a speed time graph?
You can get velocity.
Wrong.
No, acceleration.
What will give us acceleration?
Velocity over time.
Wrong.
Change your velocity over time.
Wrong. A speed time graph's gradient gives us the acceleration. Got it?
Okay. Wait. Okay.
Remember
Mm-hmm.
the slope. Look at this. This was a graph, right? This is a
Yeah.
speed time graph. The gradient of the speed time graph is going to give us acceleration. What else
Acceleration.
information can we get from speed time graph?
The speed
Wrong,
or velocity.
wrong.
If it's
The distance.
distance, yeah, sorry.
Why are you
Distance.
forgetting it? And how do we calculate the distance in a speed time graph?
Area under the graph.
Area under the graph. Exactly. And what information does a distance time give us?
Velocity.
What tells us velocity?
The gradient.
Good. So one of the best ways to understand the movements of an object whilst on a journey is to plot a graph of the position of the object over time, such as a displacement time graph or even a velocity time graph can give us the details of all the movement involved. Displacement time graph can tell us what? Okay, you can see that how distance is there on the y-axis and the time is present on the x-axis. And with time, this is as the time moves on, the distance of the particular object also increases. And the gradient tells us that, let's say, from 0 to 20, the speed was increasing,
Uh,
constant.
yes.
Over here, what was the speed?
It was constant. It was
Wrong.
about no. It was zero
Why it was 0?
because it is distance time graph. So when the distance stay the same,
Yes,
the
because
time will also
distance
stay the
is
same.
not changing. Then over here
Yeah.
again, constant speed se chalta rahega. Then a
Mhm.
little bit speed increased and then it decreased again. And we can tell all of that by looking at the gradient of that graph. The
Yeah.
simplest thing we could find from this graph is how far an object has moved in a certain time. For example, both the graphs show that in the first 15 minutes, the boat moved 150 meter, and looking at the time 40 to 48 minutes, both show that boat traveled 120 meter. But the displacement time graph is in the negative region of the y-axis, shows that boat was moving away from the starting point. वो negatively जाएगा. Then you can see in 20-25 minutes ये हमारे पास नीचे graph दिया हुआ है. 10 to 20 में क्या हो रहा है? It is going in the positive direction. Then 20 to 25, the boat is at a rest because distance is not changing. And then it is moving backwards towards the starting point again. And then it again starts to increase. Got it?
Yeah. Yep.
Good. That is how you interpret a distance time graph. Whereas in a speed and velocity time graph, gradient tells us how fast a boat is moving because gradient is distance over time, y
Mhm.
over x, and that is equal to your speed.
Speed.
Velocity time graph will also show the velocity of an water over the time. We calculate the velocity of the boat on the river that was at this point. Yeah, we can see on the velocity time graph that over here, is it zero velocity or constant velocity?
Constant.
It's a constant velocity. Over here, it's a decreasing velocity. What
Yep.
about this? This is on 0x.
Constant.
This is zero velocity. Got it?
Oh, zero. Yeah. Sorry. Yeah.
Gee, it's a 0. This is constant. This is constant.
Mm-hmm.
ठीक है, and this is also constant. ठीक है, यहाँ पे देखो एक
Yep.
दोबारा एक sudden increase आया है in a speed as well. This is how you interpret a velocity time graph, because and the gradient of the velocity time graph would tell us the acceleration.
Yep.
Acceleration is told by the distance because y over x अगर करें, y-axis has velocity, x-axis has time, and v over t is equal
Yes.
to your acceleration.
Acceleration.
Distance can be
Everything.
told by the area under the graph. The same graph, if you look at over here, can tell us the distance as well. If I
Yeah.
ask you how much distance was covered from 25 to 48, so you're going to take this whole distance.
Mm-hmm.
25 minutes to 48 minutes. This was the distance traveled. You can divide this
Yes.
into two
We have
rectangles.
to divide it in two, I think. Yeah.
आप दो rectangles के अंदर इसको divide कर दो.
Mm.
One of them is
Base
your
times height.
region A1. This
So.
is your region 2. Calculate
Mhm.
both of the areas and then add them up. Got it?
Yeah. Yep.
If we are only interested in finding a distance move, it can also work for the negative velocity. It doesn't matter that if the velocity is in the positive region of the graph or the negative, distance would always be still be the same, and it will always be a positive answer. Acceleration time graph, on the other hand, can show how the acceleration of an object changes over time. In many instances, the acceleration is zero on a constant value, in which case an acceleration time graph can be seen as well. You can over here see that acceleration is increasing from -8 to 0, and then the acceleration becomes 0 over here. And this straight line would mean a increasing acceleration. This line would mean a constant acceleration because y-axis is having what? Acceleration. Got
Yep.
it?
Yeah.
Next, we have the topic adding forces. Forces are vectors. And can you define me what is a force?
Force is how much energy is used.
Wrong. Try again.
Uh, I don't know how to describe it,
Is
but
this the rate of change of momentum?
Right.
Vector force is what? Rate of change of momentum. F is equal to ma. ठीक है. And can I write, अगर मैं acceleration की जगह can I write mv minus u over t? So it becomes what? mv minus mu over t. So what
Yeah.
is mv? Momentum.
MV is mass times velocity.
mv क्या है? It's momentum.
Oh, yeah, so
So
momentum.
force is change of momentum divided by time. So force is
Right.
defined as the rate of change of momentum. Got it?
Yeah.
Good.